All right, week number 6. Continuing to do two modules at a time. This one will focus a lot on IPSs and, of course, the ones that are Cisco specific. Whenever there's an attack, like a 0-day, when somebody finds a vulnerability that nobody knows how to fix it, we need to have a way to know that something's happening, that something new or something different is occurring on our network. An intrusion detection system watches what's happening and lets you know, hey, something's funny happening. That could be done by looking at traffic, looking at logs, looking at behaviors, all of the above. But intrusion detection does just that. It only detects and reports. And intrusion prevention actually will stop an attack. It'll not only alert that something fishy is happening, it'll stop that thing from happening. The two have a lot of common characteristics, but the main difference of an IPS is that it will react when it thinks an attack is happening. It doesn't just sit back and just let you know and do nothing. Of course, they all have their advantage, disadvantage. For example, with an IPS, you're going to have a little slower traffic because it has to read everything and has to decide whether it's going to react or not. An IPS only works locally or can work locally, but again, it doesn't react. So it's just going to let you know, like a car alarm, but it's not going to do anything. The two main types of either are the host and network based. So just as the name implies, any host intrusion detection or prevention system only works on that device as it's installed. The network one works on the network. Do you need both? Yes. Because endpoint protection is one thing, network protection is another. They are not the same. You can use a variety of network-based sensors that either are part of a firewall or on a router, a virtual machine, an appliance, all different ways that you can implement. You can also install these devices in line, which means the computer or devices, they are sending their data through. And then promiscuous is data is being copied over. So using like a span port to get a copy of the packets that are flowing through and go in another route. So from the general, we go to a little more specific. Let me just say, Snort is an awesome tool. It is difficult to set up. It is difficult to use, but if you can use it, you will wield great power. It is not a simple tool, but you being able to use it will be quite beneficial for you in the long run. iOS does have an IPS, and it has a couple things like setting alarms, dropping packets, resetting connections, denying traffic. Snort has way more power. Anything Cisco 4000 and up has the feature, but you can also install it as a virtual machine, or install it on a computer. This snort is a very powerful tool. I highly suggest looking into it. It has quite the number of benefits. It is a modern IDS IPS. But like I said, it is tough to initially install and configure. But once you know how to do that, and once you know how to make rules, you are pretty set. With any setup, you could use a network tap, which it takes what's coming through a port and sends a copy of it over somewhere else to another device to monitor, to get information. It's a passive device, so it should not affect the speed. It should not affect what the data itself. It's just taking a packet and copying it bit for bit and sending it another way. You could have multiple ports, multiple span ports to handle traffic that's coming in and traffic that's going out. There are network taps where it's all in one. The one that I have at home costs about $300, almost $400, and it does both ingress and egress at the network speed. Something more this, where any traffic that's coming in from F01 and going to F02 or vice versa, that information gets copied over to the destination span port, and that could go to an IDS sensor, that could go to whatever log management, whatever you want. If you are thinking about using Cisco to span a port, this is the command that you would have to do in global config. You set which interface will be the source, which interface will be the destination. So anything that comes in through the source that you define, that source interface, any packets that come in and out of that will go out, well, a copy of it will go out through the destination. Here's a little example of saying, hey, anything that's coming from Fast Ethernet 01 gets copied out to Fast Ethernet 02. That way, whatever's on the other end can look at it and do whatever. And then you could do show monitor to see the setup. There is a packet tracer for you to do that helps you understand how to make the local span. Module number 12 dives further, starting with signatures. A network security device has to be able to understand what is different and react on the different. There are a lot of signatures, like activities, behaviors, code, that viruses, worms, malicious traffic uses, but that's not always reliable because it's all that information is reactive. We get that information after the fact, after somebody detected it and wrote a rule for it. Reality being, with a lot of sophisticated attacks, they're not going to use common signatures. So we can have things like pattern-based, anomaly-based, policy-based, even honeypot-based. So with pattern, that's your signature. A program does XYZ. If a program does XYZ in this order, it's probably malicious. For anomaly, that's where you go for the new stuff, because it's going to do something different than what your network already does. So understanding what your network does, what's considered normal behavior for your network, that's important, because then you'll be able to find these anomalies. You'll be able to find these, hey, why is this thing acting different? Policy-based is another way of behavior. You set up what you expect systems to do, and when they don't do that, they're breaking policy. So let's figure out. Honeypots are awesome. They are like your first line of defense because they attract the attacker. So it's easy to see what they're doing and be able to react to that. There's a bunch of actions that you can do, anything from logging activity, denying actions, blocking future traffic. All that kind of stuff can be created out of the information that you get from these devices. Alerts tend to be classified into these four things: a true positive, a true negative, a false positive, and false negative. A true positive and true negative are the two that are desired. Those are the two that you want to get. You want to know when an attack is detected. You want to know when normal traffic doesn't generate an alarm. Those are good things. The false ones are not. The false positive is an undesirable. Normal traffic went through, normal traffic that we deem okay went through, but it triggered an alarm. Then that means we need to tune our system so that that doesn't happen again. The false negative is the dangerous. The false negative is when an IPS, fails to generate an alarm and attacks are not detected. That's bad. So there are devices like this one, the Firepower Next Gen IPS, that is a hardware appliance that you connect your network to. And it does things like application visibility, malware protection, URL filtering, that kind of stuff. The one that I highly recommend, and the one that will take the rest of this time, is Snort. It's open source network IPS. It is not easy to install, but it does a lot of work, a lot of good work. You can get community set rules that are available for free. Those are 30-day delayed. You could also get the subscriber rule set, which you can get for a fee, and that gives all up-to-date stuff that's happening. Here is the basic rule, the basic rule process for a snort rule. What do you want it to do? Do you want to alert? Do you want to drop? What protocol? What source IP? What destination? What source port? That kind of stuff. That's how you make a basic alarm. Snort header rules contains optional fields or additional fields. So things like, we want a message to appear. We want to detect which way traffic is flowing. We want to know the type of content. And so on. There's actually a lot. This is a really small look at what you can get in a rule for Snort. Packets that arrive on any Snort-enabled devices will go through the IPS itself. It'll inspect the packet and take any necessary action, like dropping them or allowing the packet to flow through. You can have a snort VM with multiple NICs, one for managing it, another that's just data, which is ideal. You do want to split up the management, how you connect to snort to make configuration changes versus the one that flows data. For example, if you have a potential attacker and you have snort installed, you don't want them to be able to get to the configuration of snort. You want that to be outside of their realm. To deploy snort, you can do it a number of ways. You can use an OVA file, like Cisco has in these next couple slides. You can download it from source on Cisco's website. Snort actually has its own thing. There's a number of ways that you can get it down. You can also install it on a Cisco router, for example. So again, you can go an OVA pre-install from cisco.com. You can install a virtual machine in a router. They have to be the CIS 4000 and up, of course. And this is the process that you would do that to bring that OVA up into that router. You would configure some interfaces. So here we're going to have some virtual interfaces to handle traffic coming in and out. Then we'll activate those services so that those addresses are available. Enable UDT or UTD, the Unified or United Threat Defense, and enable logging, of course. Now you want to set it up to, if you want to be an IPS, you set it with threat protection. So it'll take action versus just letting you know. You can define policies. You have some base ones, and you should always make your own. You can use the base ones as a template, as a starting point, but never rely on those. And then you can enable it on every interface that you have, or just specific ones. And then you can do a couple commands to see that it's implemented. Now, again, these are instructions that you would use when installing it on a Cisco router. A more realistic way that you could get snort running is on a virtual machine, either on your computer or on the cloud. Those instructions are on snort. Snort is in version 3. So I suggest using snort 3. I will let you know that it is a challenge. Even my competition team has some difficulty getting it installed. It is not easy. The instructions are not always clear. There's a lot of dependencies, a lot of things that have to come together to make it work. But when you get it working, when you have it configured correctly, you will get quite the information, and you will have quite the defense on your network. It's a really good tool. It's just not as easy as you'd hope to get started. Then it has a learning curve, but I mean, what doesn't have a learning curve? As always, if there are questions, please put them on Discord. If you are able to get snort working, I would like to see a report on your installation progress, your struggles, your successes. I will gladly grant you extra credit because it is a tough tool, but the reward for getting it properly configured, properly working, properly defending your network, like say your home network, is worth it.